Dear friends, welcome to my video on the technology behind virtual reality glasses. Kindly click on the CC button for subtitles. Welcome you to click the blog link in my description below to read more above the concepts of this technology. Thanks for your support. Virtual reality, VR, glasses, also known as VR headsets, have transformed the way we interact with digital environments, providing immersive experiences that were once the stuff of science fiction. The technology behind these sophisticated devices is a blend of hardware and software that tricks the human brain into believing it is part of a virtual world. This article delves into the key components and principles that make VR glasses work, from display technologies to tracking systems and user interaction methods. Display technology. The core of any VR headset is its display technology. VR glasses typically use either liquid crystal displays, LCDs, or organic light-emitting diodes, OLEDs, to project images directly into the user's eyes. Each eye is presented with its own slightly different angle of the scene, creating a stereoscopic 3D effect that gives the illusion of depth. The displays must have a high refresh rate, usually 90 Hz or higher, to ensure smooth motion and prevent the disorientation or nausea that can result from lag or stuttering images. Optics and field of view. To make the images from small screens fill the user's field of view, VR glasses use lenses placed between the display and the eyes. These lenses are designed to focus and reshape the image for each eye, creating a panoramic view that enhances the sense of immersion. The field of view in VR headsets typically ranges from about 90 to 110 degrees, which is crucial for an immersive experience but still short of the human field of view, which is about 210 degrees horizontally. Tracking systems. For a truly immersive VR experience, the headset must track the user's movements accurately and in real time. This is achieved through a combination of sensors in the headset and external tracking devices, depending on the system. Inside-out tracking, used by many modern headsets, relies on cameras and sensors on the headset itself to track the position and orientation of the user's head in relation to the environment. Outside-in tracking involves external sensors or cameras placed around the room to track the headset and controllers. Both systems allow users to look around, move, and interact with the virtual environment in a natural way. Input and interaction. Interacting with the virtual environment is a key part of the VR experience. This is achieved through a variety of input devices, including handheld controllers, gloves, and even bodysuits equipped with sensors. These devices translate the user's physical movements into actions within the virtual environment, from grabbing and manipulating objects to walking or running. Some VR systems also incorporate voice recognition, eye tracking, and facial expression detection to make the interaction as natural as possible. Audio technology. Spatial audio is another crucial element in creating an immersive VR experience. This technology simulates how sound is heard in the real world, taking into account the direction, distance, and environment of the sound source. By adjusting the volume, pitch, and timbre of sounds in each ear, VR headsets can make it seem as though sounds are coming from specific locations in the virtual world, adding to the realism and immersion. Software and development. Behind the scenes, sophisticated software algorithms work to create the virtual environments and ensure a seamless experience. This includes rendering software that generates the 3D graphics, physics engines that simulate real-world physics, and development platforms that enable the creation of VR content. Real-time rendering is particularly important in VR, as it must adjust instantly to the user's movements to maintain immersion and prevent disorientation. Challenges and future directions. Despite significant advances, VR technology still faces challenges, such as reducing motion sickness, increasing resolution and field of view, and improving user comfort over long periods. Future developments may include more advanced display technologies, such as micro-LEDs, better battery life for wireless headsets, and more intuitive interaction systems that could include brain-computer interfaces. In conclusion, the technology behind VR glasses is a complex interplay of display and optics, tracking systems, interaction methods, and audio technology, all powered by advanced software. As this technology continues to evolve, the boundary between the virtual and real worlds becomes ever more blurred, opening up new possibilities for entertainment, education, training, and beyond. Thank you for watching my video. Kindly subscribe to my YouTube channel and give a thumbs up. Thanks for your support.